Atlanta, Houston, just let you know, we're waiting on a power share discrete evaluation, then we'll give you a go for deploy at that time.
Okay, that sounds great. We're just sort of floating by here waiting for that.
And again, the power share sequence is a procedure that is intended to take into account the change that Galileo senses when RTG active cooling goes off, and also to make sure that an energy transient that the spacecraft sees does not affect power inverters A and B. And those, again, are the devices that take the output from the RTGs and condition that output for acceptable voltages for all of the subsystems aboard Galileo. Meanwhile, on the spacecraft Atlantis, Shannon Lucid reporting that they've reached a step where they're awaiting the go for deploy from mission control. They have verified that the PI, the payload interrogator, is locked on to the inertial upper stage. They've enabled rendezvous navigation. They have dead-faced the umbilicals and done their final payload checks. Next major event in this deploy countdown will be release of the umbilicals that tie the Atlantis to the inertial upper stage. So we're standing by for that word from Galileo.
Atlanta, Houston.
Houston, Atlantis.
Roger, Shannon, it's been a long time coming, but you have a go for deploy.
Okay, understand. We have a go for deploy, so we're starting out on step 5, the top of page 4-10, and just pressing on.
Roger, we concur with that.
So at 5 hours, 53 minutes into the mission, Galileo has been given a go for deploy by all of the managers and technicians and engineers on the ground overseeing the health of the various systems aboard the orbiter, the inertial upper stage, and the spacecraft bound for Jupiter. All is go, and Galileo should be leaving the Atlantis in about 27 minutes, 13 seconds. Mission Control, at 5 hours 54 minutes, we now have confirmation of umbilical release. So the cables connecting the inertial upper stage to the orbiter have been released.
That the umbilical's released. We got all the verification for that. And the IUS is moving up to 58 degrees. So it looks like, so far, it looks like it's going pretty good.
Okay, that's great news, Shannon. Thanks.
Ground telemetry is confirming Shannon Lucid's report of tilt table motion. The tilt table was at 29 degrees. It's now moving up to an elevation of 58 degrees. That's the deploy attitude. Meanwhile, Commander Don Williams and pilot Mike McCulley will be preparing for the orbital maneuvering system separation burn that post-deploy will move Atlantis away from the IUS Galileo. And we're also standing by for a step in the timeline to stop RTG cooling and to vent and purge the RTG cooling lines aboard the orbiter. We're now 25 minutes, 10 seconds from deploy Galileo. All systems reporting go across the Mission Control Center and also at Sunnyvale, the Galileo POC. Also reporting green lights all the way. We have a report tilt table now is raised up to 40 degrees, still elevating up to its deploy attitude of 58 degrees, or deploy elevation of 58 degrees.
Houston, Atlantis. We're up at 58 degrees. It took 3 plus 28. Everything looked nominal, and we're proceeding on step 7, purge, heater activation, etc.
Roger, we copy that, Shannon. Thanks.
We just finished step 8 on page 4-13, and we're waiting 6 minutes for the RTG purge stop.
Roger, we copy that, Shannon. Thank you.
Houston, Atlantis.
Go ahead, Atlantis.
Yeah, we're about 2 minutes into the RTG cooling loop purge, and our dump nozzle temperature is falling. It's now at about 48 degrees. We were wondering if you might want us to turn both of the nozzle heaters on or not.
Okay, Ellen, stand by. We'll check on that. Atlantis, Houston, for Ellen, we just think that's the normal N2 blow-through. We're happy with just one heater.
Okay, thanks.
This is Mission Control Houston now, just a little more than 17 minutes prior to deploy a Galileo, all proceeding very well in the countdown to deploy. They're currently in the steps that involve the cessation of RTG active cooling aboard the orbiter and the vent and purging of those RTG cooling lines. RTG cooling system aboard the orbiter involves water and antifreeze, alcohol essentially, circulating through the RTG. The heat is transferred from that back into the orbiter Freon loop and ultimately rejected out of the payload bay door radiators and the flash evaporator system, and they're purging the fluids that have been used for RTG cooling since launch. Those fluids have been purged. Now they're blowing through nitrogen through the piping. And again, everything going very well. We're about 16 minutes now from deploy of Galileo, and this is Mission Control Houston. This is Mission Control Houston. We're now 10 minutes from deploy at Galileo at a mission elapsed time of 6 hours 11 minutes. All very quiet aboard Atlantis, or at least the air-to-ground traffic has gotten very quiet, and all is quiet here in Mission Control. All systems green. Everything looks good aboard all three spacecraft, Galileo, IUS, and the orbiter Atlantis. And we're standing by for deploy in about 9.5 minutes. This is Mission Control Houston. We're now inside 5.5 minutes from deploy of the Galileo. All still very, very smooth and extremely quiet on all of the loops here in Mission Control and elsewhere as we stand by for deploy now in 5 minutes, 11 seconds. This is Mission Control Houston at 3 minutes prior to the deploy of Galileo. All systems still go. Lead Flight Director Milt Heflin here on the Orbit 2 shift in Mission Control has polled positions around the room. All the operators reporting systems in their areas very healthy. The orbiter looks good. The IUS looks good. Galileo looks good. We're standing by shortly for confirmation that Atlantis has gone to free drift, and that will be followed shortly thereafter by the deploy of the IOS and Galileo stack. We're now at 2 minutes, 9 seconds from deploy. This is Mission Control Houston at deploy minus 1 minute, and all still go. All systems still looking good for deploy now in 55 seconds. Thirty seconds now before deploy Galileo. We have confirmation the orbiter has gone to free drift as intended. We're now 16 seconds to deploy. 15, 14, 13, 12, 11, 10 seconds now before deploy Galileo. Standing by now for confirmation of deploy. And the Sunnyvale flight director has just confirmed the successful deploy of the inertial upper stage and Galileo. Galileo reports positive telemetry of deploy. Also, we see the orbiter performing a minus X translation maneuver to move away from the IOS Galileo stack.
On time, Houston. The spacecraft is stable. Galileo is on its way to another world. It's in the hands of the best flight controllers in this world. Fly safe.
Roger, Atlantis, we copy. That's great news. Thanks.
This is Mission Control, Houston, 6 hours, 26 minutes into the flight of Atlantis as the vehicle passes over the Gulf of Mexico. We have seen Galileo deployed successfully. That took place about 5.5 minutes ago. For those keeping records, let it be shown that on 18 October 1989, Galileo was deployed 6 hours, 21 minutes, 23 seconds, .397 into the flight of Atlantis. Now we're standing by for the separation maneuver Atlantis will perform. And that burn is coming up in about 8 minutes, 55 seconds. Also standing by for the crew to confirm that they'll be lowering the tilt table to a elevation of -6 degrees in the payload bay of Atlantis, and then they'll be doing the post-deploy set maneuver. So far, all indications are that the inertial upper stage and Galileo are performing nominally as they depart the vicinity of Atlantis.
Nothing is broken. I said continually hold it, keep it unkeyed.
Atlantis, Houston, hot mic.
No, we'll take care of it in a minute.
Atlantis, Houston, hot mic. Atlantis, Houston, comm check.
Houston, Atlantis, did you try to call?
Yeah, we've got you loud and clear now. For a while there, we had a little bit of time a hot mic, but it seems okay now.
Yeah, we're using the little microphone up here, and all of a sudden just started being open mic, and we had to hold the transmit button in for it not to be a hot mic.
Okay, yeah, we copy. I guess that was causing some other background noise too, but it seems okay now.
Yeah, it started working okay now.
Atlantis, Houston, Shannon, could you give us a status on where you are in the IUS deploy checklist?
Houston, Atlantis, right now I'm in the process of lowering the tilt table.
Roger, copy, thanks. Atlanta, Houston, for Shannon, do you expect the tilt table to be lowered to 6 degrees prior to the 2 ohms engine burn?
Okay, we understand that, and we're waiting. We'll cut it off if it doesn't get there before we get ready to do the ohms burn. Oh, I guess I misunderstood you. You were asking the question. It's almost down there. It's not quite yet. We'll zoom in and I'll give you a reading.
Okay, Shannon.
It's passing through, the tilt table is passing through 0 right now.
Okay, Shannon, we copy that. We have ample TIG slip for this burn. We'd like to just go ahead and make sure that the tilt table gets all the way down to -6, and then we can go ahead and do the burn.
Okay.
And that burn coming up in about 1:45 seconds.
It's going to be down before the burn.
Okay, that's great. Thanks, Shannon.
And the tilt table's at -6.
All right, thanks, Shannon. That's good.
This is Mission Control Houston. Shannon Lucid reporting the tilt table's down to its stowed position of -6 degrees elevation. Standing by for a separation burn coming in about 48 seconds. Meanwhile, Sunnyvale confirms that the inertial upper stage has entered into the planned thermal roll that follows deploy. So all going well aboard 3 different spacecraft at the moment in low Earth orbit. We're now at 6 hours, 35 minutes mission elapsed time, and this is Mission Control Houston. This is Mission Control. The propulsion systems officer reports 2 ohms engine ignition aboard Atlantis, and it looks good. Separation burn confirmed complete, and the residuals look good. We've also received a report via Sunnyvale that the Orion aircraft that will be supporting getting telemetry into the ground stations out over the Pacific Ocean, those aircraft are on station as scheduled. There are 2 that are supporting today's deploy. One is staging out of Kadena Air Force Base and the other out of Singapore. ARIA is an acronym, ARIA. It stands for Advanced Range Instrument Aircraft.
Houston, Atlantis, we've completed step 6, the transfer the state vector to the IUS.
Roger, copy. Step 6 complete. Cyclic transfer state vector to IUS.
This is Mission Control. Houston Sunnyvale Flight has just polled all his controllers at Onizuka Air Force Station Satellite Control Facility, and all controllers there report the inertial upper stage in good shape, in good condition. All indications from Galileo are a healthy spacecraft. Of course, the orbiter Atlantis moving away from both of those two in preparation.
Go ahead, Atlantis.
For your information, the time for the tilt table to go down to -6 was 7 plus.
Atlantis, Houston, Shannon.
Go ahead.
I'm sorry, Shannon, the TDRS was off the nose, so we had a comm dropout. Could you tell us again the time for tilt table to -6?
Sure. I just had to turn my pages back there. It was 7 plus 45 for it to go down to -6, and the MET was 6 plus 35 plus 21, and both of the tilt table position top axes are gray.
Okay, thanks, Shannon. We copy.
That was Mission Specialist Shannon Lucid reporting to us the times that it took for the motors to drive the tilt table down into its stowed position. And meanwhile, the next television we will see will be through TDRS West on orbit 6. We hope to take then a videotape playback from the Atlantis of the Galileo deploy. That would take place at an MET of 7 hours 27 minutes, or a Central Daylight Time of 7:21 p.m. This is Mission Control, Houston. We're taking some unscheduled live television from the orbiter Atlantis. We're looking from the aft end of the payload bay. This is the ring in which the inertial upper stage was housed. Of course, the IUS is no longer there.
Atlantis, Houston, just want to let you know we're getting some good TV, looks like from camera B.
Okay, it sounds great. So we just configured up here so we can look at what you're looking at.
Okay, Shannon, we copy.
This is Mission Control, Houston. Before we lost that TV signal, we switched briefly to the Charlie camera, which gave us a brief look at the indicator the crew used to tell them the elevation angle of the tilt table, and indeed it was at -6 degrees. Now we're back on the B camera, the color camera, in the aft corner of the payload bay, taking a live view from Atlantis.
Houston, Atlantis.
Go ahead, Atlantis.
We just completed step 8 on page 5-7. We just went command source MDM.
Okay, Shannon, we copy that. And if you've got the flight deck camera operating and would like to send us some pictures, we'll take a look at them.
Okay, we have pictures ready to send you.
Stand by, Shannon.
Okay, just a minute. We're going to turn it on in just a second. We have it all set up.
This is Mission Control. Houston, in this post-deploy timeline, the orbiter has been configured for throughput commanding. Essentially, it's a link between the Earth and the inertial upper stage, and indeed Sunnyvale is commanding through the orbiter and through its payload interrogator toward the inertial upper stage, and IUS ranging commands are now being sent. We're also taking at the same time some live television from the A camera, payload bay of the orbiter Atlantis. Mission Control, Houston, we're now taking a live view from the aft flight deck of Atlantis. We see Shannon Lucid in the center of the picture.
Atlantis, Houston, we'll let you know we are getting some in-cabin TV at this time.
Okay, that sounds good. Do you want us to do anything with the lights or anything?
No, Shannon, that looks pretty good.
Okay, it didn't look too good on our monitor.
Say again, Shannon?
I just said it doesn't look very good on our monitor. So I didn't know what you were getting down there.
Yeah, it looks pretty good. At first we were receiving black and white, now we're getting color. The lighting looks just great.
Okay, that sounds good.
Atlantis, Houston.
Houston, Atlantis, go ahead.
Shannon, we're about a minute to LOS on the east. We should pick you up on the west about 7:13. I wanted to give you a heads up from the IMAX folks. Just to the east of northern Luzon in the Philippines, there is a nice cyclone forming out there. You might be able to see it on this rev in just about 20 minutes or so, but we'd like to maybe take some pictures of it on Rev 7, and we'll get that to you when we get you on the west.
Okay, thanks a lot for that. We'll look for it. Maybe we can try to get some pictures. And we're going to start closing out here in just a little bit.
Okay.
This is Mission Control of Houston. We're about to go over the hill into the loss of signal area through the tracking and data relay satellite east. Should be the end of our television. Until we pick up with VTR playbacks on the next rev of the Galileo deploy.
Atlantis Houston with you through Teeters West.
We copy.
This is Mission Control. Houston, we're just a little less than 1 minute from ignition of the first stage motor on the inertial upper stage, and we're standing by for confirmation of that burn. This is Mission Control. Houston, Sunnyvale confirms initiation of first stage burn aboard the IUS. Ignition began at 7 hours 21 minutes mission elapsed time.
Atlanta, Houston.
This is Mission Control. Houston, Sunnyvale has confirmed SRM-1 burnout on time and on schedule.
Atlanta, Houston.
Houston, Atlanta.
I just want to let you know that Sunnyvale's just reported that SRM-1 is complete.
Oh, that sounds like good news. Was it a good burn?
We're checking on that right now. In the some more words on that cyclone I mentioned earlier. I think I may have understated that. It's being called a super typhoon named Elsie. Winds right now are sustained at 135, gusting to 165, and it's just east of Luzon.
Okay, we'll be looking for that. And keep us posted on what's going on with IUS and Galileo. We sort of have a vested interest in it.
Yes, ma'am, we'll do that.
Okay, thanks a lot.
This is Mission Control. Stage separation between IUS Stage 1 and 2 has been confirmed. At this point, events are happening in quick succession aboard the inertial upper stage.
Go ahead, Atlantis.
Yeah, Mike, we're all set up to send you some VTR views of the table racing and deploy and all the other events post-deploy. It was scheduled for 7:30, but we're ready now.
Okay, Franklin, we copy that. Stand by, and we'll let you know when we're ready.
This is Mission Control at 7 hours 26 minutes into the flight. Sunnyvale confirms Stage 2 ignition on the inertial upper stage.
Atlantis, Houston, SRM2 ignition has just occurred at 7:26.
Okay, thanks a lot.
Atlantis, Houston, for Franklin, we're ready to take the VTR dump whenever you're ready.
Okay, that's in work.
As we stand by to take television from Atlantis, VTR playback of the deploy of the inertial upper stage in Galileo, we would note that even now Galileo is being accelerated to an Earth escape velocity by the inertial upper stage, second stage burn.
And you should be getting a picture now. I don't know how good it is. It's not too good in our monitors, but you might have better luck. This is just prior to the umbilical release.
Okay, Franklin, yeah, we're receiving a pretty nice picture. Atlantis, Houston, for your information, SRM2 burn is complete, and as soon as we get a report, we'll give you a call.
Okay, that sounds great. We appreciate knowing that. And for your information, we've completed closeout. So we're done through page 5-10. So you can tell Steve Boone that he can quit thinking up mouths for us to do.
Okay, we copy and we'll pass that on. Atlanta Houston, I have a flight note for you on a water dump.
Okay, hang on just a second, Mike.
And Houston, on the VTR, that's the table raised to the 58-degree position, and I'm going to go ahead and switch tapes so that you can see the deploy.
Okay, Franklin, we're ready.
And while Franklin's doing that, ready to copy your note on water, Mike.
Okay, Don, as you may have suspected, since we loaded some extra water and didn't use any of it, and that coupled with our fest problems, we've got too much water. So what we'd like to do is go ahead and start a water dump as soon as possible so that we can get the SSBUV started. What we'd like to do is dump tank B to 0 and tank A to 90%. Dump duration should be about 40 minutes, and you can use your supply water dump procedure in Orbit Ops page 5-2.
Okay, we want to dump tank Bravo to 0 and tank Alpha to about 90, and the procedure's on 5-2 of the Orbit Ops.
Yes, sir. Good readback.
And I was going to return you to the orbit TIFL of 103 and 161 here, if that's okay.
Okay, we'll check on that. Stand by, Don. Atlanta Houston, Don, we're happy with changing the TIFLs as you said according to the timeline, and we'd like you to hold off on SSBUV activities until we give you a go.
So SSBUV until you call, and we'll go ahead with the 103, 161 TIFL, and here's Franklin.
Okay.
Okay, and here's some views just prior to the deploy. The thing got to be coming out in just a couple of minutes.
Okay, thank you, Franklin.
And you can see deploy now.
Yeah, that's a nice, pretty picture, Franklin. Thank you.
We've got a lot better views of the deploy with the 16 millimeter film camera with the entire spacecraft in view. We'll have to wait until we get back for you guys to see that one.
Okay, thanks.
This is Mission Control Houston. As we look now at this videotape of where the inertial upper stage and Galileo were, we now tell you where they are. Sunnyvale can now confirm that the spacecraft Galileo is hyperbolic. It has achieved Earth escape velocity and is now heading outbound toward the sun at about 7.1 miles per second. That confirmation came at mission elapsed time of 7 hours, 36 minutes.
And let me go ahead and fast forward it to where you can see the firing of the pyros in the primary aft post deploy. I got that marked in, and so I'll show it to you in just a sec.
Okay, Franklin, thanks.
As we wait for Franklin to rewind the tape and show us some more views from the orbiter, we'll also tell you that the inertial upper stage has begun a spin-up that will allow the deployment of the RTG and magnetometer booms aboard Galileo, and has successfully issued discrete pattern number 1 to Galileo, which is a computer command that tells the spacecraft to take those actions and deploy those appendages.
Atlantis, Houston for Franklin.
Go ahead.
Mr. Franklin, on that last bit of footage that we just saw, we noticed some debris, it looked like, or particles floating above and out from the IUS tilt table. Could you give us some more words from that? Do you think that stuff's coming from the RTG disconnect plumbing?
stand by. Let me go ahead and ask Shannon, see what she saw.
Houston, Atlantis, we saw stuff coming out, looks sort of like from the back of the orbiter. Maybe it was sort of ice or something, and we noticed it as soon as we opened up the, payload bay doors and started looking out. It had nothing to do with RTGs or, the coolant loop or the IUS as near as we could tell. We just think maybe it was ice in orbit with us.
Okay, yeah, I think I saw that when we first got our first payload bay TV, but we're still seeing some now on this picture, in fact, that we've got right here.
Yeah, it was. It's under certain lighting conditions. It's extremely spectacular.
Okay, so it's been kind of continuous then.
That's affirmative. It's been continuous ever since anyone looked out the window.
Okay, thanks a lot, Shannon.
Mike, concerning the water dump here, we see the nozzle temp's a little low, so I'm going to go enable the other heater.
All right, stand by, Don. We'll check with the ECOM. Atlanta, Houston, Don, we concur with enabling the other heater.
Okay, it's in work.
Atlanta, Houston, I have some more Galileo news for you.
Houston, Atlantis, did you have a question?
Shannon, I just wanted to pass on some more Galileo news to you. The spacecraft booms are deployed at this time.
Oh, that sounds great. That's a step in the right direction.
That's right.
This is Mission Control Houston at 7 hours 46 minutes mission elapsed time, confirming again that both the RTG and science booms aboard Galileo are reported via telemetry to be fully deployed. The spacecraft is on its way on a long fall toward the inner solar system. It has achieved Earth escape velocity. The inertial upper stage shortly will be, after the boom deploy sequence, will be reacquiring the proper attitude in order for the second stage of the IOS to begin a spin up to 17.4 degrees per second, or about 2.9 revolutions per minute. That will then enable the nominal separation of Galileo and IUS.
Atlantis, Houston.
Houston, Atlantis.
Yeah, Don, we've been talking about the particles that we've seen on the TV that we've got down here, and I seem to think that it may be a little bit different than what our previous experience has been in flight. We'd like you guys to give us a description as best you can of the anything you can think of: size, color of the particles, their motion, and where they're originating from.
Yeah, let's discuss that for just a minute.
Okay.
And in the meantime, should I go ahead and turn that second nozzle heater off on the water dump nozzle? Looks like it's still warming up even though we are dumping.
Okay, Don, stand by. And Don, we're happy with our configuration for the supply water dump at this time, and we'll reconfigure after the dump most likely. We'll keep an eye on it.
Okay, thanks. Appreciate it. We've been talking about the particles some there, Houston. I'm not sure we have a consensus because several different people looked at them. I thought they were the same sort of ice and leftover propellant stuff that I'd seen before that comes out of the propellant lines and the engines and stuff like that after you do the MPS dump, and it just follows you around for days. They were white in color, very bright, of course, in the sunlight, as you might expect, and they were sort of following us around and didn't seem to be emanating from any particular place, although, of course, only had primary jet firings. The particles end up moving around a little bit, as you might expect.
Okay, Don, we copy that. Thanks.
And Mike thinks that they were very small, had almost no mass, which would kind of lend some credence to that. Shannon initially thought that we might have some kind of prop leak back there in the back, and we very carefully examined all our onboard data that we had on the displays and stuff, and it looked like it was all nice and tight, which it still does. And so we sort of discounted that idea, but you know, that was her initial cut, and that was probably a good thing to take a look at all that.
Yeah, we agree with that. Okay, Don, thank you. Atlanta, Houston.
Go ahead, Houston.
And I just want to let you know that on the tags test we have completed modes 1, 2, and 3 and half of 4. We're going to stop there. We want to send you a photo of the typhoon that's east of Luzon in the Philippines, and it's got some data on it for IMAX photo opportunity if you can do it, and then we'll complete that mode 4 test of the tags. So it should be coming up to you in just a second.
Okay, should we go clear out the paper tray and get that one then?
Stand by, Don.
Yeah, Houston, Atlanta, while you're thinking about that here, Franklin is going to want to talk to you in a few minutes about the PM experiment, if you could kind of get ready for that.
Okay, Don, we copy that, and we'd like to leave the pages in the tray at this time.
Okay, I understand. Leave everything in there that's in there now.
Yes, sir.
This is Mission Control, Houston, 8 hours, 2 minutes mission elapsed time. Things have been going smoothly here in Mission Control as we've been taking television views from the orbiter, and we're about to begin a PM discussion
Atlanta,
with Franklin
Houston,
Chang.
for Franklin, we're ready to listen to your comments on PM.
Okay, Mike, I was just observing the equilibration curve on the FTIR, and I've been noticing that the curve is stabilized for a while, and then it began to drop down. I was setting up the camcorder to see if I can send you down some live pictures of the display so that Dr. Cook can take a look at it and see if it looks okay for him. We have not started any samples yet.
Okay, Franklin, we copy that.
Yeah, just give me a few minutes, Houston, to see if I can get this camcorder set up to look at the screen.
Okay, Franklin. Okay, Franklin, we got to do some configuring down here too, and we'll do that. We should be ready in a few minutes.
Okay, we copy.
Atlantis Houston for Franklin.
Go ahead, Mike.
Yeah, Franklin, just want to let you know we are ready for the camcorder downlink. And also something else you could check for us is we're having trouble panning, tilting, and zooming camera B. Wanted to see if you could do that on board.
Okay, we copy and stand by for a downlink of the camcorder.
Houston Atlantis, can you see the PGSC display?
Stand by, Shannon. Yeah, Shannon, we're getting a pretty good picture of that at this time. We're about ready to hand over to the east satellite, so we may drop it for a second.
Okay, well, let us know when you pick us up again.
Okay.
Same problem that we had before. It was that one upstairs before.
Atlantis Houston, we've got you now on Teeters East.
Okay, Houston, loud and clear.
Atlantis Houston, on the east satellite, we have KU blockage, so we'll have to get the camcorder downlink a little bit later on.
Okay, we copy.
This is Mission Control Houston. We have word from Sunnyvale that both the IUS and second stage IUS and Galileo are spinning up now for the separation of the two spacecraft. Galileo has successfully deployed all of its booms and has begun sending telemetry through the deep space network. This is Mission Control Houston. Sunnyvale reports a little less than 1 minute from separation of second stage IUS and the Galileo. All looking good at this point.
Atlantis, Houston. I want to let you know the IUS is separated from the Galileo spacecraft, and the Galileo is on its own.
Okay, good, Sam. Thanks very much.
This is Mission Control Houston. Again, we have confirmation of spacecraft separation. The inertial upper stage has separated from Galileo. Galileo now outbound from Earth's orbit toward Venus.
Go ahead, Atlantis.
Yeah, whenever you get the KU back up, I've got the camcorder all set up and showing the display on the FTIR equilibration display for the PM guys to look at.
Okay, Franklin, we copy. I think it's going to be about another 15 minutes, about 8 hours and 30 minutes, MET.
Okay.
This is Mission Control Houston, 8 hours, 15 minutes, mission elapsed time. A note for viewers of NASA Select, we're about to switch our satellite over so that the point of origin will be Kennedy Space Center to begin the transmission of some playbacks. And as soon as we do receive some camcorder downlinks from the spacecraft that we expect shortly, we'll switch back to Houston as a point of origination. This is Mission Control, Houston.
Houston, Atlantis, I've got some IMU alignment numbers if you don't already have them.
All right, Mike, we watched that and we have all the numbers. No need to read them down.
Okay.
Atlantis, Houston on the tags.
Go ahead, Mike.
Yeah, we just want to let you know that IMAX photo and flight note should be in the paper tray right on top. We want to leave all the other pages in the paper tray so we can complete our Mode 4 test.
Okay, I understand we should have the photo, and we'll try to pull it out without disturbing the rest of the stack.
Yes, sir.
Houston, the top sheet in the tray is a test message of the tags. However, the page image light is on. Do I need to do a paper advance to get the one out you set up?
Stand by, Don. We'll check. Atlantis, Houston, Don, we did a page advance down here. The image light should be off, and you can check for the page.
Okay, we've got it now.
Okay, great. Atlantis, Houston.
Go ahead, Houston.
Yeah, we see that water dump is complete, and we need an hour between the water dump and the SSBUV outgas step number 1. So we want to make sure we don't do that step 1 on the outgas until 9:30 MET.
We were just talking about that a minute or so ago, and we concur with that.
Okay. Atlantis, Houston on the IUS Galileo.
Go ahead, Mike.
Don, I just want to let you know that the IUS performance was right on from the initial analysis, and the IUS burn to completion is complete.
Outstanding. Good news, sir.
Atlantis, Houston, we see a camera over temp again. We'd like you to go ahead and cycle through those cameras and turn them off if they're over 45 degrees.
We'll go. it looks like the only one showing anything over about 36 is the mid-deck, and that's where we got the camcorder plugged in.
Okay, Don, we copy that.
Is it okay to leave it on?
Yeah, stand by. Inco's taking a look at it. We'll let you know.
Okay, and the flight deck camera is showing 36, plus 36. The rest of them are all negative numbers.
Okay. Atlanta, Houston. Atlantis, Houston.
Houston, Atlantis.
We're about a minute and a half LOS on the east. We'll pick you up on the west at 8:52, Don. And on the last two flights of the Atlantis, we'd seen an APU-2 GG fuel pump heater A's failed to operate, and it looks like it's doing the same thing on this flight. So we'd like back on panel A12, take heater, gas gen, slant, fuel pump 2 to B auto.
Okay, that's complete. And I've been panning and tilting the Bravo camera around. It seems to work okay. When I first took a look at it out the window, it was pointed directly at the aft bulkhead, and it was also panned all the way around to its stop. So I unwound it, so to speak, and it seems to be working okay, and we've got a picture on it.
Okay, great. That's good news, too.
And it also was powered down. I had to turn it back on.
Say again, Don?
When I first came back to the panel, the camera power on camera Bravo was off. I had to turn it back on.
Okay, we copy that, Don. Thanks. And we got about 30 seconds to LOS, and we'll pick you up again at 8:52 on the west. Okay, Don, we copy that. Thanks. It looks like we're approaching our typhoon. I have some words on a PM power cycle for Franklin whenever he's ready to copy. It's a fairly long note.
Okay, they're doing some retinal photography down on the mid-deck. We'll break in as quick as we can.
Okay, thanks.
Although Shannon is available to talk to you about it.
Okay. I can pass the note on to her. Like I said, it's fairly long if she's ready to copy.
This is Mission Control Houston at 9 hours 6 minutes mission elapsed time. Most recently, we've been attempting to get some TV out of camera Bravo, the color camera in the payload bay of Atlantis, and took some views as Atlantis was passing over the western rim of the Pacific Ocean. Our next television event will be a replay of Flight Day 1 activities. That replay will begin at 9 hours 21 minutes mission elapsed time, or at about 9:15 p.m. Central Daylight Time. Meanwhile, the main activities of the day have, of course, gone very successfully. The orbital tracking map, now shown on NASA Select, has a view of the orbiter as it crosses over the Pacific on this rev, and also to the right of that, a ground track, overlaid ground track of where Galileo is as it heads up and out away from the gravitational influence of the Earth. The net result of the burn that the inertial upper stage successfully performed, both the stage 1 and stage 2, is that Galileo will be slowed down relative to Earth and will begin a long drop into the inner solar system toward Venus. Earth's velocity in its orbit about the Sun is around 30 kilometers per second, and Galileo will be traveling at 26 kilometers per second when all is said and done, and will head in toward Venus. All of the events associated with inertial upper stage placement of Galileo on that trajectory have gone very well. Deep Space Network began acquiring telemetry from Galileo at about 8 hours 2 minutes mission elapsed time, and that was a little over an hour ago, so all that we have heard reported here in Mission Control shows extremely successful deploy and insertion of Galileo on its interplanetary trajectory.
Atlantis, Houston.
Go ahead, Houston.
Don, we want to attempt to thaw the topping evap core. On an L1, we'd like to take the radiator out temp to high.
Okay, we'll do that.
And when Franklin or Shannon are available, we'd like to get this PM flight note up.
Shannon is on her way. Stand by.
Okay.
And before you start talking to Shannon, I guess the flash evap controller call out here at 9:25 is overcome by events. And second quick question is, we're still go for the SSBUV outgassing at any time after 9:30 MET.
Roger, Don, we concur with that on your SSBUV, not until 9:30. And you're right, the flash evap call out is OBE.
Okay, here's Shannon.
Okay, I'm ready, copy.
Okay, Shannon, this is has to do with PM power cycle. I've got about 5 or 6 steps here that are required to perform a reset of the PM system without affecting the IR source equilibration. First step is PGSC power off at the PGSC. Second step, PGSC power off.
Wait a minute. Okay, number 1 was PGSC power on at the PGSC.
Power off at the PGSC.
All right.
Okay, second one, PGSC power off at the GEM.
Okay, PGSC power off at the GEM.
Right, then we'd like you to check the connections between the GEM and the PGSC. Those connectors would be the following at the GEM or GEM: CHJ2A, connector CHJ2B. Again, both of those are at the GEM, and then at the PGSC, connectors number 3 and number 7.
Okay, we'll check all the connections.
And then I'd like to take the PGSC power back to on at the GEM. And then you can resume the PM payload ops checklist activities at step 9 of the PM setup. And then report the status after completing step 13.
Okay, we'll do that.
Thank you, Shannon.
Okay, I have a good copy on that. We'll get with that and work.
Thanks, Shannon.
Houston, Atlantis, this is about PM again. Did you all get the picture that we sent down the camcorder of the PGSC screen?
Yes, Shannon, we only got about 30 seconds to a minute of that before we had to go. I guess it was a handover teeter cease, and then we had KU blockage, so we didn't get that much, but we did get some.
Okay, because Franklin's question was just it was equilibrating, and it's within, spec. It was just that it was going down lower. And his question was, should we just go ahead and start the samples since, the equilibration was going down a little lower? It wasn't that we needed to start all over again unless you all saw that and wanted us to do that.
Okay, Shannon, we copy that. We'll get with the PI and get back to you.
Okay.
Atlanta, Houston.
Go ahead, Mike.
Yeah, Don, I should have mentioned this before. This is on the subject of PM. Is Shannon still listening?
Yeah, she's listening.
Okay, the PI believes that we may have a problem, and he hopes that this will fix it. This is essentially just cycling the computers for us, so we would like you to go ahead and step through this procedures that we just read up to you.
Okay, we copy all that, Mike, and we'll get it in work.
Okay, thanks, Franklin.
This is Shuttle Launch Control. We are at T-minus 3 hours and holding. We're in the final hours of the STS-34 launch countdown at this time. Everything is proceeding smoothly here in the firing room, at the Launch Control Center, and at Launch Pad 39B. Liftoff of Atlantis' fifth mission into space is planned for the opening of today's launch window at 12:50 p.m. Eastern Daylight Time. And we have the STS-34 flight crew uh, with a pumpkin decorated in an astronaut suit. We've got Commander Don Williams. This is going to be his second flight today. We've got Mission Specialist Franklin Chang Diaz making his second flight as well. Mission Specialist Shannon Lucid, this is her second flight. And Mission Specialist Ellen Baker making her first flight today. Pilot Mike McCulley also making his first flight today. Flight crew will be departing for the launch pad in about an hour and 10 minutes or so after they get their weather briefing and don their flight suits. Meanwhile, at the launch pad, the ICE team is continuing their inspections of the vehicle and launch pad area. Closeout crew is making the cockpit and white room ready for the flight crew's entry. Standing by now to get live video of the flight crew getting into their launch and entry suits. They have completed their weather briefing with the flight directors in Houston. And now in the flight crew quarters, astronauts getting into their flight suits. They're called crew altitude protection systems, and they have consist of a helmet and a communications cap. These are pressurized garments, and they do wear gloves and boots. There's pilot Michael McCulley. This mission specialist Shannon Lucid. Crew does need assistance getting into these suits. They are bulkier than the other suits that were worn previous to the STS-26 mission. There's mission specialist Franklin Chang Diaz. They do wear gloves and boots with these anti-exposure, anti-gravity suits. And we've got the flight crew for STS-34 departing the operations and checkout building. Now on the third floor of the checkout building, and go down to the first floor in the elevator. And we got the flight crew here, led by Commander Don Williams. This is Shuttle Launch Control at T-minus 2 hours, 31 minutes and counting. Flight crew now has arrived at the launch pad. Now making their way across the orbiter access arm to the white room so they can prepare for entry into the orbiter's cockpit. Primary objective of the mission today is to deploy the Galileo spacecraft from Atlantis' payload bay and into low Earth orbit. We've also got the shuttle solar backscatter ultraviolet instrument in the payload bay joining Galileo. Several secondary payloads will be being flown in Atlantis' middeck. One of them involves polymer morphology. We've got a lightning research experiment, radiation measurements, and an experiment to conduct microgravity effects on plants, and a student investigation on ice crystal growth in space. Closeout crew members are preparing to assist flight crew members with their helmets and the rest of the gear they will carry on board during ascent. STS 34 Commander Don Williams now preparing for his entry into Atlantis' crew module. Williams is a captain in the United States Navy. He was born in Lafayette, Indiana. He was pilot for the STS 51D mission, the fourth flight of Discovery, which was launched April 12, 1985. Pilot Mike McCulley is a commander in the United States Navy. He was born in San Diego, but considers Livingston, Tennessee, his hometown. McCulley was selected as a NASA astronaut in 1984 and is making his first trip aboard the shuttle today.
Thank you.
Mission specialist Ellen Baker was just boarded the crew module, shaking hands with members of the closeout crew on her way in.
Houston.
Mission specialist Shannon Lucid is being prepared to board the orbiter at this time. She was born in Shanghai, China, but considers Bethany, Oklahoma her hometown. She was selected as a NASA astronaut in 1978. Lucid's first shuttle mission was STS-51G, which was launched on June 17, 1985. Mission specialist Franklin Chang Diaz is also standing by to climb aboard the shuttle Atlantis. He was born in San Jose, Costa Rica. He will be making his second flight today since being selected as an astronaut in 1980. He made his first flight aboard Columbia on Mission 61C, launched January 12, 1986. During the six-day mission, he participated in the deployment of the SATCOM KU satellite, conducted experiments in astrophysics, and operated the Materials Science Laboratory. We've gotten a go to begin our pre-flight calibration of the inertial measurement units. We will be proceeding on with the attitude determination at this time. The mission timer can show either Greenwich Mean Time or mission elapsed time and can be adjusted to within 1/1,000,000th of a second, either by ground command, via uplink through the orbiter computer, or by the flight crew through the use of their flight deck display and control panel keyboard.
And city altimeter reads 14.6.
UCL copies 14.6.
Verify range pickup to count at T-minus 20 minutes.
Okay, you gotta go.
This is shuttle launch control at T-minus 20 minutes and holding. Got less than 2 minutes now remaining in our built-in hold. Now looking at a live shot of the shuttle training aircraft making approaches here at Kennedy Space Center, flying around, making assessments of the local weather here.
All stations after transition to Ops 101, discontinue all LDB PMU reads for the remainder of countdown.
NASA Test Director Al Safji has briefed the launch team on recycle options
OTC ISL.
and has
Ready to support Ops transition.
asked that they all verify they have the proper programs running in their computer consoles to support the remainder of the countdown.
As your office transfer complete.
That's a Fox.
878, 879 complete. About 880.
The site is located between the launch pad and the runway. about 20 seconds away now from picking back up with the count at T-minus 20 minutes.
Countdown clock will resume on my mark. 5, 4, 3, 2, 1, mark.
T-minus 20 minutes and counting.
Tip 889.
Atlantis' onboard computers will be transitioning into the terminal countdown configuration. We will dump the computer memory of one of the 4 primary computers to look at it, make sure the OPS1 program has been stored properly and that there are no unexpected results.
That was a mistaken call.
OTC, PLT.
OTC, go ahead.
We've configured the ohms interconnect.
Copy, and we're ready for you to perform MPS helium reconfiguration.
12 to.
That leaves 285 only, is that affirmed?
That's affirmative.
T-minus 10 minutes, 30 seconds and counting.
All non-mandatory LDB traffic for remainder of count.
During this hold, we will get updates on the weather situation here at Kennedy and at the transatlantic abort sites, using radar at both locations and also pilots and aircraft to make assessments of the weather situation.
Go ahead. 958, 959 are complete, and 960 is not performed. Thank you, sir.
T-minus 9 minutes and holding.
9 minutes and holding.
This, again, will be a 40-minute built-in hold. This is planned, and our window for launch today opens at 12:50. T-minus 9 minutes and holding. This is shuttle launch control.
Go ahead.
Are we going to do an IMU misalignment correction or a launch poly?
We'll take a look at that. Launch poly is not required, and we'll get back to you on the IMU.
Copy.
This is shuttle launch control at T-minus 9 minutes and holding. Got about 26.5 minutes left in this built-in hold of 40 minutes. If we are to resume the count on time, the countdown clock would start at 12:41 p.m. this afternoon, giving us an opportunity to launch at the opening of the window at 12:50. Still monitoring the rain showers in the area here at Kennedy and looking closely at the TAL sites for the last minute-by-minute updates. When the countdown resumes at T-minus 9 minutes and counting, the ground launch sequencer will be in control. This master computer program will issue the commands to perform the final task required to put the vehicle in launch configuration. It monitors as many as 1,000 different measurements during the final 9 minutes to make sure they do not fall out of predetermined limits. All personnel here in Flying Room 1 have now switched over to the same communications channel and will stay on that channel from now through launch. This is shuttle launch control at T-minus 9 minutes and holding. Got about 15 more minutes left in our built-in hold here. We'll now be going to mission control in Houston, finding out what's going on there in preparation for today's launch.
This is Mission Control Houston. In the flight control room at the Johnson Space Center, flight controllers have all given go for coming out of the T-minus 9 hold. However, we are no-go for launch based on weather at the Kennedy Launch Center, and also we are looking at the weather situations at our transatlantic abort sites. Those are Zaragoza, Spain, Morón Air Base, Spain, and Ben Guerir, Morocco. The Flight Dynamics Officer, along with the JSC Weather Officer, the Kennedy Weather Officer, are coordinating the most recent weather data from sounding balloons and local observations at the Cape and the TAL sites.
NTD Flight 212.
Stand by, flight. Countdown clock will start in 4 minutes. Go ahead, flight.
Okay, we're going to be go on RTLS, and we're standing by right now to give the crew an update for Ben Guerir weather.
Okay, I copy, launch truck. Go ahead and give me the update, flight.
Okay.
Atlantis, Houston, with updates on your RTLS and TAL.
Ready to copy, Frank.
Roger, RTLS forecast remains the same for winds, altimeter, and weather. KSC 15. We're going to go with Ben Guerir 36 for TAL. Forecast weather there is 9,000 broken, 20,000 broken, 6 miles in haze. Currently reporting 8 miles, no visibility problems. Forecast winds 350 at 10, gust to 15. Altimeter 3015.
Countdown clock will start in 3 minutes.
Okay, we copy, Frank. Thank you very much.
Roger, and that's nominal aim point and nominal speed break at both sites.
9 and hold at 5, waiting our call.
At T-minus 7 minutes 30 seconds, the orbiter access arm will be retracted away from the vehicle.
We get a go from flight before 5. PLS NTD. PLS will go for OAA retract. Go ahead, NTD. Okay, configure to hold at 5. Countdown clock will hold at T-minus 5 for your request.
We start a retraction of the orbiter's access arm, and we are configuring to hold a countdown at the T-minus 5 minute mark, right before we start orbiter auxiliary power units.
NTD Flight 212.
Go ahead, flight.
Okay, we're going to be go on TAL, but we're going to have to switch sites to Zaragoza. So we hold at T-minus 5. We can give the crew an update.
Copy.
Flight controllers now looking at Zaragoza as our TAL site, and we'll be updating with, flight crew will be making these updates to the orbiter's computers at T-minus 5 and holding. T-minus 6 minutes, 30 seconds. Clock will be holding at T-minus 5 minutes to update the orbiter's computers for a TAL site of Zaragoza.
Countdown clock holding at T-minus 5 minutes. Our countdown clock is holding at 5 minutes.
T-minus 5 minutes and holding.
Go ahead.
Ready for your briefing.
Roger.
Chamber coolant valves of the main engines will be open to prepare for engine start. At the 1 minute point in the count, an engine ready indication will be given. At this time, the 3 main engines are being gimbaled and positioned for start.
OTC 1081 is complete. Copy.
T-minus 3 minutes and counting.
PLS will go for ETLO2 pressurization.
Pressurization of the external tank liquid oxygen tank for launch has started. The gaseous oxygen vent hood will be retracted from the orbiter in the next few seconds.
PLT, clear caution and warning memory. Verify no unexpected error.
T-minus 2 minutes, 30 seconds. Orbiter test conductor has requested pilot McCulley to clear the caution and warning memory system. Liquid oxygen tank now reported at flight pressure.
Warning memory is cleared and no unexpected messages.
Copy, and flight crew, close and lock your visors, initiate O2 flow, and have a good flight.
T-minus 2 minutes. Flight crew's been instructed to close their visors.
We're ready, thanks.
let's go for ETLH2 pressurization.
We have a go for pressurization of the liquid hydrogen tank. Less than 2 minutes away now from launch. All systems are go.
1 minute.
1 minute, 30 seconds. T-minus 45 seconds. T-minus 31 seconds.
Let's go for auto sequence start.
We have a go for auto sequence start. Atlantis' 4 redundant computers have primary control of critical vehicle functions through liftoff.
20.
T-minus 20. T-minus 15. 11. 10. 9. We have a go for main engine start. 6. 5. 4. 3. 2, 1. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
Houston now controlling.
Solid clear. Roll program.
Roger, roll, Atlantis.
Roll program initiated, about 110-degree roll maneuver. Guidance confirms a good roll maneuver. 3 engines throttling back now to 65% as Atlantis passes through the area of maximum dynamic pressure. Throttle's now at 65%. APU's looking good. Velocity 2,000 feet per second. Velocity now 1,400 feet per second. Downrange distance 3 nautical miles.
Atlantis, go at throttle up.
Engines now throttle back. Engines now back to 104%. All systems performing well. Standing by for separation of these solid rocket boosters at 2 minutes and 4 seconds. Velocity now 2,700 feet per second, downrange 10 nautical miles. Separation of SRBs confirmed. Velocity now 4,200 feet per second, downrange 33 nautical miles.
Atlantis, performance nominal.
The performance nominal call. Performance nominal means that we are getting the expected thrust from the combination of the SRBs and the 3 main engines. Velocity now 4,800 feet per second, downrange 53 nautical miles.
Atlantis, press to ATO, select Ben Guerrier.
Press ATO, select the Ben Guerrier.
press to ATO call means that Atlantis could lose performance of one engine and still make a safe orbit.
Group Ben Guerir 109.
Group 109.
Velocity now 11,000 feet per second, 278.
Press to MECO.
Press to MECO, Houston.
Downrange 293 nautical miles. The press to MECO call assures that Atlantis can reach safe and nominal engine cutoff if one engine should fail.
And this is just prior to the umbilical release.
Okay, Franklin, yeah, we're receiving a pretty nice picture.